Next is reflection of light by spherical mirrors. Like a plane mirror, spherical mirrors also reflect light. And while reflecting light, spherical mirrors also obey the laws of reflection of light, which are obeyed by plane mirror or by rough surfaces or those surfaces which undergo regular reflection. So let's draw a curved surface, which is, let's say, a concave mirror. If a light ray falls on its surface, then it is reflected in this direction. This portion of light is known as incident ray. This portion of light is known as refracted ray, and then if we draw a normal at this point O, then this normal will be in this way. And if we measure angles, that is angle of incidence and angle of reflection, then angle I will be equal to angle R, which is first law of reflection. And second, at the point of incidence, incident ray, reflected ray, and the normal all lie in the same plane. So laws of reflection are obeyed by curved as well as plane surfaces, and reflection takes place on the same pattern. It does not mean that if the surface is curved, then it will not obey laws of reflection. But why are curved surfaces used? What is the use of these concave and convex mirrors? It is very important that the concave mirrors, they form inverted images. We can write their few characteristics: concave mirrors and convex mirrors. That if plane surfaces and curved surfaces all they obey same rules of reflection, then why do we use these curved surfaces which form concave and convex mirrors? Number one is that concave mirrors form inverted images. Whereas convex mirrors, they form erect or upright images. Erect or upright images. Erect means if you place this marker in front of the mirror, you will see its image just like this, that its tip will be in downward direction. But if you will place it in front of a concave mirror, you will see its image just like this one, that is completely inverted. Upside down inverted. Size of the image also varies with change in position of the object, but generally they form bigger images when object is placed inside. Also remember this condition, that they form bigger images when object is placed inside center of curvature. Object is placed inside center of curvature, then they form bigger images. And when object is placed inside center of curvature, then convex mirrors, they form smaller images. What is meant by bigger and smaller? We always compare image size with size of object. If image size is greater than size of object, that is considered as bigger image. And if it is less than the size of object, then it is taken as smaller size. These are two very important characteristics. Third one is concave mirrors, they form real images. And convex mirrors, they form virtual images. So these are very important features of these two types of mirrors, which distinguish these two types of mirrors from plane mirrors, because plane mirrors, they form different types of images, which we shall study in our next topic as well. How can we find the location of image? For example, if an object is placed somewhere here in front of this mirror, where will its image be formed on this mirror? To locate this, we always use a formula for lenses as well as mirrors, that is 1 over f is equal to 1 over p plus 1 over q. And this is the formula which is helpful in locating the image in a mirror. How can we locate? Let's say this is a concave mirror. This is its center, which is also known as vertex or pole. Let's say this is center of curvature. The central point is focus. If an object is placed at any point behind the center of curvature, then how is its image formed? We know that when we emit light rays from a light source, and those light rays, they fall on, these are light rays, they fall on this object, then they are reflected by this object, and these light rays are reflected in different directions, but we shall take one or two light rays which are important in making image. This is first light ray which falls from this light source, which is somewhere here. It falls on this object and it moves in this way. That is, it moves parallel to principal axis. When it moves parallel to principal axis and it strikes the mirror, then after reflection it passes from this focus and comes in this direction. This is the first light ray. Second one, which falls on this object, it goes to this pole and is reflected in this direction. And the point where these two light rays intersect each other, an image is formed. Now we shall label that what is F, P and Q in this figure. The distance from this image, it is image. This is object. The distance from this image to this pole, that is known as image distance, it is denoted by Q. The distance from this point F to this pole, it is known as focal length, it is denoted by this small f. And distance from this object position to this pole, it is known as object distance, it is denoted by P. So these are the terms which we wrote in this formula, and these are the terms which are interlinked with each other. So if we can find any of these three quantities, we can find focal length of a mirror, or we can find image distance from the mirror by using this formula. But when we have any two noun quantities, then we can find third one. So this formula is applicable on both concave and convex mirrors. But we wrote two important characteristics here, that image is virtual and image is real. Whenever image is formed and that image is virtual or that image is behind mirror, generally images which are behind mirror, they are virtual, then for such images f is negative, that is focal length is taken negative and image distance is taken negative. Then you will put the value of f as minus. For example, focal length of a mirror which forms a virtual image is 10 centimeters, then we shall write in this formula as 1 over minus 10. And same as the case of image distance, you will put its value negative whenever the image formed is virtual. That is our today's topic. Thank you.